Today we'll be talking about radicals. And you might remember radicals from Algebra 1. And what a radical is, it's a symbol that looks like this. We normally think of that as square roots, but at some point we can have like the third root, where that little 3 is in the front. But this right here is your radical symbol. Now, factors are two numbers that multiply to a given number. So I know that sounds confusing, but let's look at the number 8. So factors of 8, you could say, are 2 and 4, because 2 times 4 equals 8. You could also say 1 and 8 are factors of 8, because 1 times 8 is also 8. So that's what it means to be a factor. In a perfect square, it's a number you can take the square root of with no decimal remaining. So like 10, you can't take the square root of 10 and you don't get a whole number. So 10 is not a perfect square. 16 is a perfect square because the square root of 16 is 4. Now, a radical expression is in simplified form when these conditions are true. No perfect square factors other than 1 are in the radical. No fractions are in the radicand, and no radicals appear in the denominator or fraction. So this term, radicand right here, that's just a fancy word for square root or the radical symbol. Now, I think it'd be a good idea if we wrote our perfect squares up here up until 12. This way, what we can do is if we're ever looking for a perfect square, we have them up here on our paper. So when we simplify radicals, what we want to do is we want to break up this number into factors where one of those factors is a perfect square. Now, you have to be strategic about this. You can't just say, oh, let's just do 2 and 12. 2 and 12 are not perfect squares. So yes, 2 times 12 does equal 24, but we want a perfect square. So we can do 4 and 6. So when we do that, always remember to bring down this square root symbol, because then you get a completely different answer. We're just breaking up this square root of 24 into square root of 4 times the square root of 6. Well, we know the square root of 4 is 2, and we can't break up the square root of 6 into anything, so we just leave this square root of 6 alone. And that is our answer. Number 2, we can break this up into the square root of 4 and the square root of 5. And again, the square root of 4 is 2 times the square root of 5. We can't break up 5 any further, so we leave it like that. This one we can break up into the square root of 25 and the square root of 3. We can simplify or take the square root of 25 and we get 5. And then the square root of 3, we can't simplify that any further. So we just say we bring the square root of 3 down. Now with number 4, you can break this down a couple ways. You could say, oh, this is 36 and 2. And then say, because the square root of 36 is 6. And then we can't simplify the square root of 2, so we bring that down, and that's our answer. However, if you don't see that 72 can be broken down into 36 times 2, you can do it another way and say, okay, let's try, we can do the square root of 9 and the square root of 8. And say, okay, the square root of 9 is 3, but we can break up the square root of 8. The square root of 8 can be 4 times 2. Now remember, we still have this 3 out in front. The square root of 4 is 2, and then we can bring this down still. 3 times 2 is 6, and we get the same thing as we got up here. So you don't need to figure out the biggest perfect square that you could divide our original number by, but you may have to do more than one step. If you just left your answer 3 times the square root of 8, that's wrong, because you can break up the square root of 8 into the square root of 4 times the square root of 2. Right, now we're down here, we're going to multiply these radicals. The square root of 3 times the square root of 3 would be the square root of 9. Well, the square root of 9 is just 3. And the square root of 6 times the square root of 3, 6 times 3 is 18, so we have the square root of 18. But you can simplify this now. 18 is 9 times 2. And then the square root of 9 is 3. So our final answer would be 3 times the square root of 2. So you really need to know your perfect squares and to recognize what can you divide your number up here by to get a perfect square. Here, 4 times square root of 5 times the square root of 5 is square root of 25. 4 times square root of 25 is 5, and we get 20. Square root of 10 times square root of 2, we get the square root of 20, but then we can break this down. We can break this down into the square root of 4 times the square root of 5, and then we get 2 times the square root of 5. One of the most common mistakes I see students make is they'll get rid of the square root symbol with this step here. You only get rid of the square root symbol if you're taking the square root. See, from the square root of 4 down to 2, the reason why the square root symbol is gone is because I took the square root of 4. Here, I didn't take the square root of 5, I just left it alone, so I need to make sure I keep that square root symbol there. Okay, I want you to pause the video and try numbers 9, 10, and 11. So these should be your answers. When you're multiplying numbers, you want to keep the stuff inside the radicals together. So that's why I don't go do 4 times 2 times 14, because 4 right here is outside the radical. So it stays outside the radical down here. But since I have 2 and 14 both under square roots, I can multiply them together. And number 10, once you do 3 times 12, you get 36. You cannot simplify the square root of 10. There's nothing that breaks down and as a factor of 10 that is a perfect square. And then number 11, you had to multiply 2 times 8 first to get 16, and then you can break up 24 like we did in this example up here, number 1. And then once you break that up, you then can multiply 2 times 16 to get 32. On the next page, we're going to talk about rationalizing the denominator. What that means is that you have a square root in the bottom of the fraction. You're not allowed to have that. That's improper math. So what we need to do is, when we have that situation, we need to multiply the top and bottom of that fraction by the denominator. So like in number 15 here, we can't have the square root of 3 in the denominator, so we multiply the top and bottom by the square root of 3. And when we do that, we get 2 times the square root of 3 on top, divided by the square root of 3 times the square root of 3 is the square root of 9. So then we get 2 times the square root of 3 over 3. And that is our final answer. In number 16, we got to multiply the top and bottom by the square root of 2. So then we have 4 times the square root of 2 over the square root of 4. Now you may want to try to cancel out these 4's. You can't, because one of the denominator is under the square root. But when we simplify this, I'll write it down here instead. So we have 4 times the square root of 2 over the square root of 2 is, the square root of 4 is 2. Now, these two numbers are outside the square roots, so we can simplify that. 4 divided by 2 is just 2. So our final answer will be 2 times the square root of 2. So always look for that. I didn't do it here in this example here because 2 divided by 3, you can't simplify that, so it just gets left alone. But in number 16, you can simplify that. Now, in number 19, we can do a bit of a shortcut because 21 and 3 are both under square roots. So it can be written under one big square root like this. And then we can say, okay, 21 divided by 3, that's just 7. So then we just get the square root of 7. And we don't have to do all that rationalizing. You would still get the same answer, but because we were able to divide this part on the inside and get a whole number, it made life a little bit easier. Now in number 20, we have these two numbers that are both under square roots. So we can write that as 8 times the square root of 6 over 2. Now 6 divided by 2 is 3, so we can just write that as 8 times the square root of 3, or 8 square root of 3. And that is your answer. Again, you could have rationalized it, but it would have been a little bit more work. And also notice that I'm not dividing the 8 here. Whoops. I didn't divide this 8 by 2 as well, because 8 is not under the square root symbol. Number 21. So 8, and then 10 over 2. And then we can do 8 times the square root of 5, because 10 divided by 2 is 5. And since we can't simplify 5, like we can't break up 5 into a perfect square factor, this is our final answer. Now, number 22, okay, you may start and say, okay, 12, and then square root of 7 over 2. But 7 over 2, you can't divide that. It doesn't work out that way. You get a decimal. You don't get a whole number. So then we have to go to the the rationalizing route. So the other examples, we didn't have to rationalize because when we did 10 divided by 2, we got 5. When we did 6 divided by 2, we got 3. 21 divided by 3, we got 7. 7 divided by 2 would not give us a whole number, so we need to multiply the top and bottom by the denominator, which is the square root of 2. So 12, 7 times 2 is 14, so we get the square root of 14 over the square root of 4. The square root of 4 is 2. And now since both of these two numbers are out of the square root, we can simplify those and say 12 divided by 2 is 6. And then we have 14. Now we got to think, can we simplify the square root of 14? Is there a perfect square that I can divide 14 by? And that's why I think it's important to have the perfect squares written up on your notes so that you can refer to it. And the answer is no. You cannot simplify the square root of 14. So then our final answer is 6 times the square root of 14. So I hope that this was a little bit of a refresher from Algebra 1. Just keep in mind you need to know your perfect squares and that you want to sometimes look for shortcuts. Like for these problems, number 19, 20, and 21, you could have multiplied the top and bottom by the denominator and rationalized it, and you would have gotten the same answer. So don't think you always have to look out for shortcuts, but they definitely will help. So I hope you enjoyed the video. Make sure you like and subscribe.